Ladies and gentlemen, boys and girls, this is Mark Anderson for Kellogg Community College, and today we're going to look at simplifying some expressions which have rational exponents. And we've had exponents before, but these exponents have fractions or rationals. They also are going to remind us of what to do when we have a negative exponent, also what to do with some basic exponent rules in general. And I'd like to take the first part of this video to just go over some ground rules about what to do with exponents. If you have two exponents with the same base raised to different powers, so m and n, you can add these m and n's together. You can go n plus m, which means that if you had a to the second power times a to the third power, you could have a to the fifth power, or n plus m. If you had a letter like a to the n raised to the m power, then you would multiply these two, so this would be n times m. Or if, for that example, if you had a cubed raised to the fourth power, that would be a to the 12th power, because that would be 4 threes, or 4 of the 3, or a3, 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 which is a to the 12th. Our last rule to remember is the quotient rule. If you have n over a to the m, then you subtract these two, so n minus m. So if you have a to the 7th divided by a to the 4th, then you have an answer of a cubed. But there's a situation in this case where you don't actually have the numerator being the biggest, but you have the denominator being the biggest. So let's take another example of a to the 7th divided by a to the 9th. Well, 2 minus 9 is negative 2, and we can rewrite that as 1 over a squared. And this is another situation where we have to think about what happens with a negative exponent. The negative exponent is going to do one of two things. The negative exponent is going to move something from the numerator into the denominator, or from something from the denominator into the numerator. So this example of 1 over a to the negative 2 can be brought to the numerator, just a to the positive second power. Now, in another rule, right? Another rule from a previous chapter dealing with exponents. If you had a fraction, like a to the m over a to the n raised to the negative 1 power, that would flip the fraction on its head, a to the n over a to the m. So this is a lot of rules from previous chapters to kind of keep straight, and I want to highlight each of them. This is the product rule, which allows you to add the corners of these exponents. Here's the power rule, and the power to the power rule means you multiply these. This is the quotient rule, and the quotient rule applies for when the numerator is bigger than the denominator, but if the numerator is smaller than the denominator, then we have to go to the negative exponent rules, which are here with 2 stars, and here with 3 stars. So that's a lot of previous material to know before you even start working on these problems. So you may want to take a quick refresher on some earlier videos or tutorials on exponents, and that might be good for you to survey before we continue. Because what we're going to do is take a look at powers here, and these powers, instead of having whole number exponents, they have rational or fraction exponents, and that has its own rule. In fact, if you have a root of something to the nth root, this nth root is called the index, and the power on the inside is going to have some, the base on the inside is going to be raised to some power. Well, then this gives you a fractional relationship of inside out, or inside over index. I like inside out, it has a better ring to it, but really it's inside over index. And most of the time the m is 1, so if we ever have like the square root of 25, another way of writing that, since this is the index of 2, the square root, and that's the power of 1, another way of writing that is 25 to the 1/2 power. And oh look, here's our first example, 25 to the 1/2 power. Now we can rewrite that as a radical right here, and that's going to be 25, the square root of it. And we normally wouldn't put the 2 there in our final answer, but this simplifies down to 5. And again, I will make this disclaimer that we are only considering positive values of these answers. Plus or minus will be accounted for in later chapters, like the quadratic formula. But for the sake of this video, we're not going to be looking at the positive or negative nature of that. So in problem number 2, it looks like we have to remind ourselves a little bit about the negative rule. The negative rule means that if you have a negative exponent, it moves that whatever it's touching or whatever it's connected to, that gets moved to the opposite fractional location, and then the negative drops. Then we can simplify that even more by going 1 over square root of 16, which is 1 over 4th, and lo and behold, we do not have a radical in the denominator. That's good to go. In problem number 3, we now have another negative into the exponent here, and we're going to flip this on its head because that's what fractions do. When it's like this is a whole number over 1, this is a fraction, so flipping this on its head is the equivalent of putting 1 over 16 divided by 49. Then we are going to make that the positive 1/2, and also this makes the radical of 49 over 16, which due to the quotient rule of radicals, we can split those up, and that would be the better choice since I can see that the square root of 49 is 7 and the square root of 16 is 4. Sometimes I would be able to simplify it here, but 49 cannot be divided by anything that 16 can be divided by. So that is our answer for problem number 3. Problem number 4, continuing on with our thought about our radical. Now this negative 1/4 only touches the x, so this blue box is the only thing that moves to the downstairs location. Now what you might be thinking is like, oh, what I'm going to do is turn this into x and turn this into the 4th root of x, but in fact this is the power of 1, and due to our quotient rule we can subtract these two, so 1 minus a 4th is the same thing as 4/4 minus a 4th, which is 3/4. So that is what's going to be my x, because if I use the quotient rule that it's m minus n or n minus m, depending on how I wrote it, you would subtract these two, and that would give you x to the 3/4, which then I could rewrite as the 4th root, that's our index, to x cubed, which is our power. Alright, so for problems 5, 6, 7, and 8, for problem number 5, what I'm going to do here is rewrite that negative 3/5 into the denominator, since that's going to eliminate the radical there, or the negative for me. And yeah, I know since the bases are the same, and like in the problem before the bases are the same, I could have added straight across as well, because 2/3 plus a negative 3/5 is the same thing as 2/3 minus 3/5. So in basically just keeping up with the negative exponents, I will be subtracting these two. 2/3 minus, 2/5. I said thirds a bunch of times too, I bet I did. 2/5 minus 3/5 is going to give me negative 1/5. So x to the negative 1/5 power, or 1 over x to the 1/5, which I can write it as 1 over the 5th root of x. Now, a lot of times your teacher may want you to continue this problem because we shouldn't have a radical in the denominator. And to get rid of the radical in the denominator, it probably would have been better to go back up to this step and multiply top and bottom by x to the 4/5. And the reason why I chose 4/5 is because when I add these two exponents, my denominator just makes x to the 5/5, which is 1. And then my numerator is x to the 4/5, which would then give me the 5th root of x to the 4th. So this would be my simplified radical without having any radicals in the denominator. And I could have done it over here too, but I would have had to have thought to myself, geez, what would I have to multiply this by to make it up to, x, and that would be the 4th power under the 5th root, because 1 plus 4 makes 5, and then the 5th root of x to the 5th is just x. And doing the same thing top and bottom, because that's the law of algebra, you would multiply by 1, that would give you this expression. Now, a lot of times your instructors are going to just have you stop here. But if your instructors say, well, you got to make sure that you rationalize every denominator no matter what root it's under, this is what you do. So in problem number 6, the power to power rule applies here. So before I move that, well, I mean, I guess I could move that y to the negative 2 up to the numerator here. Let's do that. Let's do that. And you, if you took notes in my class and you noticed that, oh, hey, he's doing it a little different. Yeah, there's more than one way to do these problems, and I think we've been getting rid of the negative exponents as fast as we've been able to. So I think this is acceptable here. So then what I have now is the power to power rule, where these corner exponents get multiplied. So I have to go 1/3 times 6, which is 1/3 times 6 over 1, which is 6/3 or 2. So this gives me x squared. And this is y squared to the 6th power. That's y to the 12th. And so there, my friends, is what we have for problem number 6. Problem number 7, a little bit of a break, because in problem number 7 there is no negative exponents, so we are just going to use the quotient rule and subtract these two. So 3n minus n, or 3n minus 1n, is the same thing as 2n. So x to the 2n is the answer to number 7, and boy, there's just not much else to do with that problem, is there? In problem number 8, since I have a negative exponent, I'm going to rewrite it without the negative exponent to a to the 2n in the numerator, a to the 4n in the denominator. And again, I mean, you can decide on how you'll want to do this here, because you could have also went straight across and added the corner numbers, but this is just one way I did it. So 2n minus 4n is negative 2n. So this is a raised to the negative 2n, or 1 over a to the positive 2n. Because that moves it from the numerator to the denominator, and that also gets rid of the negative there. Another way you could look at it too is that we've had 2 of them on top and 4 of them on the bottom, so that you do some cancellation and you're left with 2 on the bottom. All right, so for our final 2 problems here, look at that. We've got a negative again. So there's a couple different ways to tackle this. One way to tackle it is to rewrite it with a negative, which you can totally do. Instead of this case, what I'm going to do is I'm going to go power to power rule. I'm going to take the 6 and multiply it by the negative 2/3, and that's going to give me negative 12/3, which gives me negative 4. So a to the negative 4, which is 1 over a to the 4th. And now for problem number 10, kind of a quick way to end the video here, because it's going to kind of wrap up nice and tidy here. If I write this without the negative exponents, this is x to the 2/3 times x to the positive 1/3. Notice how it just kind of loop-de-looped up to the top there and got rid of the negative. Then I would add these corner numbers, because you would add them straight across, and 2/3 plus 1/3, I'm not going to write down the work for that one, is going to be 3/3. And 3/3 is the same thing as 1. So that's the answer to problem number 10. Well, thank you very much for watching this video. I hope it has helped out with some of your tricky problems, but that review at the beginning of all the different exponential rules and then to add in the fraction rules, it's a little tough, but I appreciate you watching, and do your homework and ask questions, please. Thank you very much.